All right, let's get started. Well, hi everyone, and thank you for joining us today. I know it was a hard choice between this session and lunch, thank you for being here. Some people in the first two rows didn't have a choice, but for the rest of you, we'll try not to disappoint. So in this session today, we will explore how Redis is evolving to meet the demands of the modern apps when it comes to performance, scalability, and intelligence. And we'll also talk about how that reflects in our latest work on Azure. I'm Slava Koltovic. I'm a principal product manager and product lead for all things Azure Redis. And with me here today, Benjamin Rinat from Redis Inc., as well as my colleagues, Catherine Wang and Shruti Patak from Microsoft. And we will walk you through what we've built, how it helps across real-world scenarios, and where we are going next. But before we do that, let's take a step back. It's been a decade since we first launched Azure Cache for Redis. At this time, Redis was just gaining the momentum in the development community, but it very quickly became one of the most, if not the most popular caching solution on the market. And what we've seen since that time is the rapid growth, and not only in Redis usage, but also in what app demands from it today. Over these 10 years, the number of internet users has doubled, and internet traffic has grown 7 times. And that put all the new requirements on the apps that we build today, be it mobile apps or web apps or any other kind of applications. Apps needs to be faster, more resilient, and globally available. And in this kind of environment, Redis is no longer your nice-to-have performance booster. It became a critical component for keeping latency low and responsiveness high, especially for systems that powers API, AI agents, real-time analytics, and transactional workloads. And Redis itself has evolved to match those expectations. What started as a cache has become a comprehensive real-time data platform. It now supports everything from session store, streaming analytics, PubSub messaging, and gaming leaderboards. And more recently, Redis has found a key role in AI workloads, powering vector search, semantic caching, and agentic memory for agentic applications. So we knew it was time to take Redis on Azure on the next level as well. Our goal was to create something fully managed and deeply integrated into Azure, but also built for the next wave of distributed and AI applications. And that's exactly what we delivered with Azure Managed Redis. So today we're excited to share that Azure Managed Redis is now generally available. It's cloud-native, enterprise-grade Redis platform built in collaboration with Redis Inc. and designed to help you move faster without sacrificing control and stability. I have a short video that highlights what we've built and why it matters.
Today's intelligent applications need fast access to data, robust throughput to handle high volumes of requests at scale. By adding an in-memory cache, you can lower latency and significantly boost your app performance while offloading traffic on your database. Supercharge your apps with Azure Managed Redis, a fully managed in-memory data store solution designed for the hyperscale cloud, enabling you to build faster and more cost-effective generative AI applications. Beyond caching, Azure Managed Redis tackles your toughest use cases, from improving AI app performance to session management, while integrating with your favorite Azure services. Azure Managed Redis seamlessly delivers the latest Redis innovations across all tiers, including Redis Search and a multimodal data model to go beyond key value with JSON, Vector, time series, and more. Backed by up to a 5 nines of availability SLA with active-active geo-replication, Azure Managed Redis is prepared to meet the most pressing demands of all your mission-critical applications. With a few clicks, you can tailor your memory and performance to deploy a fully provisioned instance that best fits your needs, optimizing for costs and resource demands. With numerous compliance offerings, enterprise-level security, and password-free authentication with Microsoft Entra ID, you can trust Azure Managed Redis to protect your data. Start building fast apps faster today with Azure Managed Redis.
All right, that's Azure Managed Redis in a nutshell. And it brings together everything we've learned over the last decade and applies it to modern cloud-native systems. It's much faster with multi-core support and Redis Enterprise internals. It's more affordable thanks to simplified pricing across all the SKUs. It's feature-rich with all the features available virtually across all the SKUs as well. And it's reliable, backed by 5 nines SLA and zone redundancy by default. And it's also developer-friendly. We already seen great momentum, great customer momentum with Azure Managed Redis through our public preview period. It has been transformational for increasing performance, reducing costs, eliminating bottlenecks, and improving data agility. You see some of the customers here on the slide, and some of them here with us in the room. So thank you for trusting us through the process. So moving forward, let's take a look what's new as we move Azure Managed Redis into GA. So one of the biggest improvements with AMR is how we structured SKUs. All tiers now give you access to the full set of Redis capabilities, be it vector search, active-active geo-replication, semantic caching, advanced models, pretty much everything. The difference between SKUs is purely performance and cost. You choose the memory you need, the memory size you need, and then you pick the performance tier that matches your workload. And we have 4 of them for you. Flash optimized is massive, cost-effective storage that uses a mix of RAM and disks. Then we have memory optimized for large but less latency-sensitive caches. We have balanced tier for general purpose apps that provide some common ratio between memory and CPUs. And we have compute optimized tier for high throughput scenarios. With these 4 tiers and all the memory size, you can find the ratio between performance and memory that matches your workload needs and pay only for what you really use. And Azure Managed Redis is not just flexible, it is incredibly fast. So thanks to fully reworked backend and Azure and Redis Enterprise internal and tighter integration with Azure, AMR can deliver up to 15 times faster or higher performance than the same size SKUs on Azure Cache for Redis. And that's even before you factor in pricing, because when you do, the advantage becomes even more dramatic. Not only you are getting significantly higher performance, but when you account for a lower cost, the performance per dollar improvement is a step change. And that makes AMR the most cost-efficient Redis offering on Azure we ever had, and the clear choice for all the new workloads that need low latency, high-scale data access. One area where Azure Managed Redis truly shines is reliability. With active geo-replication setup, you get 5 nines availability SLA. That's an industry-leading level of uptime that makes AMR suitable for your most critical workloads. And it's easy to set up. Whether you use Portal or CLI, setting up active geo-replication takes just a couple of minutes. Even if you are running in a single region, AMR still gives you 4 nines availability by default through built-in zone redundancy with no extra configuration and no extra cost for you. So whether Azure Managed Redis powering your API responses or your AI agent memory, you can count on it to be resilient and highly available. It's globally available as well. At launch today, we have Azure Managed Redis live in over 50 Azure regions, including all the major markets. And our goal is to reach all public regions in the next couple of months, with sovereign clouds coming by the end of 2025. One of the most useful new capabilities on AMR is independent scaling of memory and performance. Historically, if you needed more throughput, you had to pay for more memory even if you didn't use it. And if you needed more memory, you were locked into the higher compute tiers. With AMR, those constraints are gone. And now you can scale memory and performance separately, which means that you can fine-tune your cache configuration based on how your app actually behaves. And it gives you much tighter cost control. You can optimize for latency and throughput without over-provisioning, and you can increase your memory without incurring extra or unnecessary compute cost. One of the other features that we added to Azure Managed Redis is how flexible it is when it comes to clustering. We support 3 different cluster modes, so you can choose what works best for your applications. So OSS clustering mode matches the native Redis clustering model. It charts your data set across multiple nodes, but it requires your client, your application, to be cluster aware. So that gives you the horizontal scale and a really good fit for high throughput scenarios, for high throughput workloads that are already using native Redis clustering logic. Then we have enterprise clustering, and this is where you get high performance without exposing complexity of clustering to your application. It presents cluster as the single Redis instance, but it does shard data behind the scenes to increase throughput. And then the new thing that we released with GA is no cluster mode. And this is your true non-clustered Redis deployment. It behaves exactly like standalone open source Redis instance. And it's ideal for lift and shift migration efforts or for the workloads that simply don't need sharding or don't need clustering. It will give you the full compatibility without any client changes. We're also investing into making sure that our developers can build secure and powerful applications with Redis. We have added support for Entra ID, which means no more static passwords or shared secrets. You can now use Azure Native Identity to securely authenticate to your Redis instance with multi-user support and the ability to integrate into existing Azure Airbag and policy models. With new .NET abstractions like hybrid cache and output cache, you can plug Redis into your existing .NET applications with minimal setup. We also partnered closely with Semantic Kernel, our agentic framework, to make sure that AMR, Azure Managed Redis, works well for agentic memory scenarios. And we're also investing in tools that make Redis more approachable and productive, specifically for your inner loop workflows. In addition to the traditional key values pairs that Redis supported from the beginning, over the last year, it did some incredibly powerful data types that unlocks new use cases. I will walk through some of them that you see on the slides here. So probabilistic data structures like Bloom filters give you extremely memory efficient way to detect duplicates and check and test membership at scale. The Redis query engine lets you run queries over your key space. Built-in time series allow you to ingest, store, and query timestamped events. And finally, Redis JSON brings rich support for storing and querying JSON documents. So you can store the whole JSON blob, you can request or query for specific fields, and you can even update these fields on the Redis instance without retrieving and deserializing document on your client. And in the past, all these features were only available in our high-end enterprise tier. And with AMR, they are available across all the SKUs and across all the tiers, including the smallest ones. And finally, it's demo time. So one of the most traditional and time-tested use for Redis is to accelerate reads from a database. Whether you're storing user profile, product catalog, session state, whatever, Redis sits in front of your database and offloads repetitive queries, reducing latency and pressure to the backend. With the performance improvements that we've done in Azure Managed Redis, this pattern becomes even more useful, especially when used or paired with the high throughput database like Azure SQL. To show you what AMR looks like and how this scenario looks in practice and how to get the most out of the both platform together, I would like to invite Catherine to the stage.
Okay. Thank you, Slava. So I'm going to show you how to use Azure Managed Redis and how it reduces the application latency with the ones built using web app and SQL. So this is the Azure portal. In the search bar, if we search for Azure Managed Redis, we now have a single standalone service entry point for Azure Managed Redis. This is the new resource we just shipped and GA'd as of yesterday. Alternatively, if we go to create a resource and search for Azure Managed Redis, we will see a separate card entry point for easily create an Azure Managed Redis resource. So let's take a look. You can read more overview information if it's new to you. Click a Create button will jump to the Create workflow. Let's create a new resource group. These are all the basic information required for any Azure resource. Let's give our cache a name. And let's leave East US as the region. Like Slava mentioned earlier, we now support more than 50 regions across Azure to cover all the common scenarios and your business need. In-memory is the most recommended and popular data tier. This means all your data will be stored in the RAM memory for quick access. We know a lot of customers start with 3 GB, and balanced is a very popular option because you have just the right amount of CPU to memory proportion for the quick key value access scenarios. So we are secure by default, like all other Azure services nowadays. We recommend you use the private endpoint so you can be connected to a virtual network. Let's try to add a private endpoint. This makes sure only resources within this VNet can access Redis. And as a data service, this is very critical to the enterprise security. Next, active geo-replication. So configuring active geo-replication will bring 2 major benefits to your environment. Firstly, if your application is globally geo-distributed, you want your server to be able to both read and write to the local cache. And Azure Managed Redis would take care of all the data sync happening behind the scene, so you don't have to do any extra coding or management on the data consistency across multiple instances of your Azure cache, Azure Managed Redis. Secondly, if you have 3 or more instances, this will bring up your service level agreement up to 5.9, which is unparalleled across industry. So let's try to create one.
Good.
Yes. Yeah.
We are already in the East US, so suppose we have other game servers deployed, let's say Italy North. You can see adding a replica, which is another instance of Azure Managed Redis, is made ever so easy with the new Azure Portal experience. Advanced settings. This is where we configure the additional features or extra layers of configuration and security. A very significant value add with Azure Managed Redis is you can install modules. And Redis Search, this is where we enable all the AI scenarios with vector similarity search. We will talk more about this later. Other settings you may care about, always keep TLS access by default. These are the clustering policies. Like we introduced earlier, the non-clustered is for 100% compatibility with your current Redis environment. And the customer managed key. So if you have any enterprise level security requirement, this will make sure all the persisted data is secured with your custom key encryption. Let's skip through the tags. And this is the overview page for all the settings we have configured. Notice that we are prioritizing the cost estimate, so everyone is conscious about their Azure billing. We may have to wait for a minute or two, but let's come back to this. So after creating an instance of Azure Managed Redis, how do we use it in our application? Let's look at the second diagram here. If I have a web application and a SQL data store for persisting all the data, for example, product catalog for an e-commerce website, there might be queries to access individual items or the overview page. And the queries might be running repeatedly over and over again, costing some amount of time. So in this scenario, there's really no point for overly running the queries. And instead, from the architecture perspective, you can consider to store all the key value data in the Azure Managed Redis instance. So this will make the data retrieval a lot faster because everything is cached in memory. And Redis is essentially a key value in memory data store, so that makes it perfect for caching scenarios. You may wonder, how do I do this in my application code? Well, let's take a look using .NET as an example. This is the e-commerce web app we were talking about. So you see all this product information is currently stored in an Azure SQL database. And like a lot of customers would do, like let's browse through some individual items. Oops, let's try again. So I just played around with this demo earlier, and we have some cached data. So let's look into the Azure Managed Redis instance. Because I set up everything within a virtual network, so I can't really access the Azure Managed Redis instance from my local laptop. So instead, I set up a Jumpbox virtual machine. So what this is doing is this virtual machine is also part of the virtual network and is configured with extra level of security, for example, corporate network only. So this makes sure that in the testing, debugging, diagnosing scenarios, the data access is secure. And when talking about security, we make sure the data persistence, the networking, and the data computation are all secure. This is critical for a data service like Azure Managed Redis. While this virtual machine is loading, let me show you how the networking has been configured. So this is the Azure Managed Redis instance. Firstly, we support the data computational level of security because your application code will never need to store the password or connection string to access it. You see, this is the Microsoft Entra authentication support. And we added the web application to be an owner of this Redis instance so it can securely access the data within it. Next, if we go to the administration and the private endpoint, we could see this Azure Managed Redis is connected to a private endpoint, which is within a subnet of a VNet. And if we navigate to the private endpoint and then the virtual network, we could see this is the VNet that connects all the resources. And we have multiple subnets We can see one dedicated to the database, one for the web app, and then cache, and this is my JumpBox virtual machine. So this makes sure all the data access happens within the virtual network and makes sure your application is secure end-to-end. Let's go back to our virtual machine. So earlier we were clicking through the eShop website, and what's stored in the Redis cache. So remember we were looking into each individual items. For example, the second product, if we click into it, yeah, smartly, this entry expired already because we want to make sure all the entries are in sync consistent with the latest data. But some examples of the data entries that we stored and cached earlier, this is the product information for another product with ID 8. And we could see for the ones we have accessed, a similar record would be written into the Redis cache. By the way, this is the Redis Insight tool. One of the recommended methods we tell our customers to manage their Azure Managed Redis data. And going back to our source code, so what would it take to write caching data into Azure Managed Redis? If we go to the services, product service cache side, we could see now it only takes one line of code, hybrid cache.get or create async. So with this one line of code, it's basically telling the application to look for a value in Redis. If it exists already, return it. If not, we create the value and then put it in Redis for future use. And you can see this async delegate function is where we can run the SQL database queries, entity framework, for example. So now it's very easy to cache data from any queries with SQL or other web API calls. And this library is part of the .NET 9. If we go to aka.ms/redis/hybrid cache, you will see the documentation for it, and you can learn more advanced scenarios such as evict by tag. So adding Azure Managed Redis to your application now is only one single line of code, and we have similar client libraries across all other languages and the framework. Okay. So that is how Azure Managed Redis can work better together with SQL application and web. Next, I would like to introduce my colleague Shruti to talk more about the Redis search and AI scenarios.
All right, thank you, Catherine. All right, before we start looking into how Redis improves AI scenarios, first let's start looking at how the user needs and user requirements have evolved over time. So Redis, as we all just saw, enhances traditional workloads by accelerating SQL queries and offloading database load. But with emergence of generative AI, Redis has to play a crucial role in modern AI workflows as well. So it has inbuilt capabilities like for vector support, and which powers concepts like vector similarity search, semantic caching. We'll look all of those in a little bit. So yeah, let's start looking into how Redis is powering Gen AI applications and driving them to be faster, more smarter, and then more cost effective. So before we start looking into it, these are some of the main challenges that the generative AI or agentic workflows today face. The first one is personalization. Users, oh, sorry. Thank you. Sorry. So before we start looking into how Redis powers generative AI scenarios, these are the challenges that generative AI scenarios face today. So users expect the apps to be intelligent enough to know and memorize their preferences in terms of languages or any other prompts that they had given to the LLMs in the past. And this requires saving and recollecting a lot of information at very low latencies. Complicated LLM queries can take many seconds. Your applications could have user surges, or your users could be in a different region or a different country. But no matter what the situation is, customers expect timely responses, and that's crucial to maintain customer attention. And then finally, LLM calls are not free. Each call adds up. And in using larger context windows, that makes your LLM calls even more expensive. So Redis is a familiar and a mature technology that offers solutions to all of these problems. And most likely, you already have Redis in your tech stack. So let's start looking into how Redis solves all of these problems. So the first key use case that Redis powers is vector similarity search, or RAG. This is the most core component of majority of the AI use cases, essentially, responding to customer queries and pulling data from a data source of your choice. So Azure Managed Redis has native vector support, which powers storing and searching these vectors in real time because of its in-memory design. So that it powers RAG, real-time RAG, essentially. The next is storing information, agentic memory. If you have multiple agents communicating to each other, storing states, or agents maintaining the intermediate states of your execution, or you want to store chat history, user session information, Redis is a great memory store for all of those scenarios. And then let's talk a bit more about the semantic caching scenario that is also becoming a very popular use case for Azure Managed Redis. So in traditional scenarios, in absence of caching, when a user queries LLMs, the call will go to the LLM for every user query. Even if it's the same query, you will still make a call to the LLM. But you can cache the query technically, and then cache the text of the query using traditional caching. But obviously, that's not very effective because these queries are natural language queries, and they're not usually repeated verbatim. That's where semantic caching comes into the play. Semantic caching solves this problem by storing the vector embeddings of the user queries, and then new queries are compared via similarity search. So with Azure Managed Redis, you get vector support inbuilt, and then you can cache and retrieve responses based on semantic similarity rather than the exact text. So obviously, this reduces calls to your LLMs, cuts latency significantly, and then obviously, you can also control cost because you have smaller context windows, lesser LLM calls. So I have a quick demo to demonstrate semantic caching. Let's switch to the app. OK, this is a very simple Streamlit app that I have written to demonstrate the power of semantic caching. And obviously, it's powered by Azure Managed Redis and OpenAI. Since it's a chat agent, let's chat with it. So for example, let's say I am curious about the sky. Why is the sky blue? And let's see how long does it take to spawn. OK, it's running. It's running. It's a call that goes to the LLM. It could take a few seconds, depending on which endpoint I'm going to hit and everything. It's still running. OK, it took 8 seconds. So now this is powered by semantic caching. So obviously, if I try the same query again, it will work. But then semantic caching means even if it's not the exact same text, it should still work. So if a next user comes in and types something like, why does the sky appear? Sure. So it's not the same text, but semantically, it's the same question. So you can see the second user got the response from a cached response, and the latency was under a second. You can see the drastic improvement in latency because of the semantic caching. And you can see the prompt that it used, what this does, this one. It's textually different, but it's semantically, it's exactly the same meaning. And then you can have this in your production and potentially wait for your users to use your cache and load it up and wait for customers to ask a lot of similar questions. Or if you have the expertise, you know what kind of questions to expect, you can load it up with a list of known frequently asked questions. For example, we are talking about semantic caching, and I know a lot of you will have questions about semantic caching. So I loaded it up with some frequently asked questions about semantic caching. So let's start with, say, something like, how is semantic caching useful? So even though none of the users asked for this question, I had preloaded this frequently asked question because I anticipate users asking similar questions. So you can see the actual prompt is what are the benefits of semantic caching, and the query that I asked was this one. So textually they are different, but semantically they are the same. And that's where the power of Redis semantic similarity comes into the picture. So moving back to the semantic caching, just let's look at the under the hood. What does the code look like? So there are a lot of libraries out there which help you with the semantic caching implementing your semantic cache. I'm using the Redis VL library today. You can see to instantiate a semantic cache, you need a vectorizer, which will take your user query and translate it into a vector embedding. There's a threshold, distance threshold, which you can tune to figure out or determine how similar your user queries have to be called the same. And then there's a Redis client that it takes to connect to your Redis instance, the Azure Managed Redis instance. That's it. That's all you need to instantiate your semantic cache. And then the main logic, it's very similar to caching that you've used in other scenarios. So you start with looking for the user query in semantic cache. So check if your semantic cache has a response for it. If yes, return back the cache response. And if it doesn't exist, then you make a call to the LLM. And then obviously you'll store the response from LLM so that the next user, when the next user comes in, you can respond with a cached response. We talked about this a little bit. How can you optimize your semantic caching further? How can you make sure it's you're set up for success? So there's two strategies. Obviously, the online caching, the one that we saw, you wait for customers, your users to come in, ask questions, and that's how you load up or populate your cache. Or you can start out with loading some pre-generated FAQs that you know your users are going to ask frequently. Right? Like you have expertise, you know what your users need, or you have a history of supporting customers, you know what the questions come in, load them up. Or if you have appliance manuals, instruction manuals, or policy documentation, you can even ask LLMs to parse out those documents and generate a list of frequently asked questions. That will definitely help improve your semantic caching success. And then semantic caching usually works well when the scope of the user queries is limited. So semantic caching becomes a great scenario for IT help desk, HR and employee portals, for policy-related questions, or your customer support agents, where you know the customers are going to be asking questions about your product. So you can load them up. You can load up your semantic cache with a bunch of frequently asked questions and save a bunch of LLM calls. And then there are some scenarios where semantic caching is obviously not recommended when the data is refreshed very frequently or goes stale very frequently. For example, stock prices, weather information, breaking news. Those kind of scenarios are not very well suited for semantic caching. And then there's also scenarios where you need 100% factual accuracy. Medical advice, legal advice, even though a lot of symptoms sound similar, they might not be the exact same problem. So if you need 100% factual accuracy, you might want to not do semantic caching because you might lose on some accuracy there. And then some best practices essentially to make sure you have the right similarity thresholds configured based on your scenarios. Some scenarios are OK with lower thresholds. Some scenarios need higher thresholds. You can log and analyze your cache misses and then tune your similarity threshold. That's the distance threshold that was used to instantiate a semantic cache. And then you should also consider clearing up your cache periodically based on the lifetime of the data that you are caching. So then that would, you should also set some cache invalidation strategy so your application knows how to deal with data when you're running out of memory. And then some scenarios could benefit from a combination of semantic caching and actual exact text matching. So both the things together used can make caching very powerful for some scenarios. To wrap up this topic about Redis and AI, I would like to reiterate on two main takeaways. The first is Redis is a great choice for all the critical use cases that you see in your AI applications. So Redis helps accelerate and optimize the core core AI's use cases that you have. And then Azure Managed Redis can do all of them at the same time. And then secondly, most of you might already be familiar with Redis. You might already have it in your tech stack. GenAI already has a lot of new concepts that you need to learn on. One less thing to learn for implementation would be to use Redis. So you can simplify your applications, you can simplify your architectures, and reduce your learning curve, get started with Redis, and then implement your AI scenarios at the same time. So that's pretty much what I wanted to cover with Redis and AI. We have, as you've been seeing, we have worked with Redis, brilliant minds at Redis to bring cutting-edge innovations to you all with Azure Managed Redis. And obviously, there's more on the horizon. And to talk about what's next, I would like to welcome Benjamin Renou, the CTO of Redis, on stage. Thank you.
Hi. Thank you, Shruti. This is it's a great presentation, and it's a pleasure to be here and talk to you about Azure Managed Redis and all the great things that you get from it. So the first and the most important thing about Azure Managed Redis is that it is, in fact, Redis. It's the real Redis. It is the Redis that is used by over 10 million applications worldwide. It's the Redis that is known and loved by millions of developers, an API that's easy to use. We just talked about how you can get to productivity with just one line of code. It's the Redis that has an unparalleled ecosystem of tools, developer tools, frameworks, production support software, just about anything out there, Redis is supported. It's also the Redis that has the best, from the home of Redis, it has the best support, the best expertise. So whenever you need something, you know that it's out there. The other thing is that you also get the latest features. You get the most exciting development on Redis. So for example, everything from a small but most often requested feature, which is hash field exploration, to something much bigger, like the world's fastest vector database. So you get all the new developments, you get all the stuff that we're working on, and there's quite a few things. I'm going to cover a few today, but there's a lot more. But first, let me address a little bit what you get from Redis Enterprise. What is it that makes Azure Managed Redis different? There are many, many things, and in a word, it's speed and power. Well, that's actually two words, really, but you know what I mean. And let's look at, I'll talk about speed in a minute, so let's look at power. And one of the core features of Redis Enterprise is that we have multi-core capabilities. So we're able to much better utilize all the cores on a big machine, but yet make the whole thing look like one server through federation. That's a very powerful feature that makes better use of the hardware that you get on Azure. We also support active-active. It's a unique feature which provides basically local read and write performance across regions. So if you have a large application, active-active is a great feature to have. It also gives you up to 5 nines of reliability, protecting against a region failure, node failure, just about anything your application can survive. Finally, one of my favorite little stat of in the whole technology world is that when Redis came out, the speed of DRAM was just about the same as the speed of NVMe 6 is today. So DRAM back then, Flash today, you have similar performance profiles. So what we've been working on at Redis is the ability to essentially leverage SSDs for less often used values to give you much, much bigger caches at affordable prices. And so one of the innovations that you'll see is Redis Flex, where you get access to SSDs. And much bigger caches. It really changes a lot of the way that you use Redis because you have much less to worry about in terms of some of the value management that Shruti was talking about, which is how often you have to evict data, how often you have to be very careful about what you put in your cache. You can put a lot more, and it's all handled for you. What are we working on next? Again, because you were getting the real Redis, you get all the innovation that we're putting into it. Redis 8 was just announced, and we've added native support for all the new exciting data types that we've talked about: time series, Bloom, search, JSON, and of course, vector set. Now they're all native to Redis. What that means is that you get from Redis all of the qualities, Redis Enterprise, all the qualities that you get normally, things like reliability, replication, management, all of that, and security, all of that gets now added to these new data types. In particular, you can now define ACLs that apply to all of these, and that makes a big difference in terms of being able to manage your data safely and correctly. As always, Redis is synonymous with performance, and we are making some big improvements in the latency department. So we are like 20 of the most common commands that people use out of the Redis API now are seeing significant improvements. We're seeing 36% improvements in ZAD, 28% for S members, and 10% for edge get all. So these are pretty commonly used commands, and they're going to go much faster. Finally, we are implementing dual channel replication, which is a fancy word for saying better replication, faster replication, more reliable, and getting back to this question of making sure that you are able to deploy with complete peace of mind. Finally, we have Redis for AI. We've talked about AI just now for a long session. Shruti walked us through some of the key use cases. Redis is bringing to AI what Redis has brought to mobile and the web. And that's session caching, data caching memory for, used to be applications, now it's for agents, agentic memory. Of course, we started with our vector database, which is, again, one of the fastest in the world. And we've brought a new data type to Redis called vector set, which is a very, it was actually designed by Salvatore, the original author of Redis, who's still working working with us and developing new features. And vector sets make vector development much, much easier, faster, and lets you get going with your vector applications very quickly. We're adding to that new services, our semantic cache service and our agentic memory service, which will be coming this year, and that you will be able to use in addition to, of course, the core services in Azure Managed Redis. With that, I would like to bring back to the stage Slava, who will tell you more about next steps.
Thank you, Benjamin.
Thank you.
All right, we're close to the end, and we covered a lot today, from the foundation we've built over the last decade to where Redis is headed for AI and beyond. So let's talk about what's next. First of all, I repeat, Azure Managed Redis is generally available now, which means you can trust your production workloads to it and start building on it today. So no need to wait anymore. With improved performance, flexible scaling, all these new features that we just discussed, and scalability and security of Azure, it's a great foundation for building both traditional distributed applications and new agentic applications that we've been hearing so much about during this conference. Now it's a great time to get hands-on. So you can create your first Azure Managed Redis cache in the portal, or you can deep dive into documentation, architecture, and code samples. Everything you need to get started is here on the screen. It's available through these QR codes. So please take pics if you want to. And we will continue the conversation. So I think we have about 5 minutes for Q&A right now. And when it's over, we'll be waiting for you there outside of the room. And please stop by our booth. We have a booth at the hub in data and analytics section. So please stop by and feel free to ask any questions you have. So with this, we have the microphone in the middle. So if you have any questions, we are here to answer. Thank you.
Hi, thank you for the presentation.
Thank you.
Question on one of the use cases that perhaps are not in the range of best practices, right, for it. So structured data. We have a use case when we take we speak with a large data set of structured data, right? Performance is not so good, right, in terms of time to respond to end user. So we are looking potentially for Redis to help us. But then we are not wanting to cache the response, right? What we are looking for is ability to cache the part of a data on which the response will be based, right? And not for a long time, but just for the the conversation on particular topic, right? Because then we can predefine some most common queries, and this we can get the performance even now to OK level, right? But then if you want to freestyle speak with this data, then it's a problem, right? So we would be looking into getting this initial amount of data that we need to respond to this initial query. Let's say I'm asking for about portfolio of projects which I manage, right? So I get this data, I cache this in, and every follow-up question that I have on this, if we can cache this, then it would be super quick, right? Is this scenario possible with Redis, or?
Yes, I think that's exactly how we intend to have the semantic cache be used. That's a very common use case. I think that's the one that Shruti was talking about in terms of sort of, anything with a long tail of data, it lends itself very well to this sort of caching. Anything that distributes very evenly in terms of frequency and doesn't aggregate on the semantic proximity, that's where you don't get nearly as many benefits. But I think the use case that you're describing lends itself very well to that. In terms of the size of the data set, so let me also put a caveat there, which is everything you talked about with respect to the size of the data set, the size of the memory pieces, and so on, that is on a case-by-case basis. Generally speaking, we're seeing applications out there that are managing pretty massive amounts of memory, up to like 2 terabytes. So it covers a great number of these apps out there. Once you get to petabyte or more, then you really do need to look at something else, and then you need to really partition the data that you want to kind of keep cold versus hot. But for the vast majority of apps, we're finding that it works very, very well to follow exactly that pattern.
Thanks.
Thank you.
Yeah.
Hello. Excuse me. I'm a software developer, and I have an Azure web app. We just put Redis in, and our Azure engineers just learned how to do it and everything. So how bad is he going to hate me when I tell him to replace the Azure Redis cache with this?
So the question is the migration from one service to the other. So two things. So once again, you have to look a little bit at the specifics of your app. How much of it you some people use caches in a way where you can sort of recreate it on the fly, where you don't really rely on the cache for persistence. In that case, that's sort of the easiest kind of scenario, because all you have to do is really just rebind your endpoints and you're good. The interface, the API is the same. Basically almost everything else is going to be completely compatible. If you have persistence, at that point you do have to copy the data over and orchestrate your transition. We are working together with Microsoft on a feature that will let you do essentially one-click migration. That's going to be coming at some point soon. But in the meantime, if you do have to do it, we're happy to talk to you about the strategies to migrate your data. It's not that difficult, but it does take a little bit of forethought.
Okay.
And to summarize, so today you can do the migration using open source Redis tools, but you will have to migrate the data yourself, and you will have to switch over your applications to the new endpoint.
That's right.
We are adding the capability to reuse the same endpoint you used to have on the cache in the next couple of months. Yeah, I'm looking at my engineering team sitting here, so in the next couple of months. And then the kind of one-click migration coming later this year for everything.
Having said that, I will say one thing, which is that if you ask one of the common LLMs out there how to do this, they'll give you very detailed instructions, and it's really not that difficult.
Okay.
Yeah.
All right. Thank you very much.
Thank you.
You're welcome. Thank you.
All right, I think with this we will wrap it up here. So as I said, please find us at our booth if you have any more questions. We'll be happy to answer this. Thank you.
Thank you for coming.